Hello everybody, how you doing? This is Mr. Dowse, and in today's lesson I'm going to cover more complex proportion problems. I have a video before this one that covers the concept behind proportion and simpler proportion problems. But these problems right here are more complex, and these are the kind of problems I'm going to give my kids on tests, quizzes, and whatnot. So here we go. I'm just going to jump in and solve this. If you notice, right off the bat, this problem looks pretty intimidating. It's not just a number down here on the bottom where I would normally cross multiply to solve for the variable. It actually has a number and a variable. So I say this is a problem, proportion problems with more than a variable. So what we have here is a variable with a number. If you ever see a variable adding and then adding a number or subtracting a number after it, you always want to start off by putting parentheses around this portion of the proportion. And so when you cross multiply, you're going to see straight off the bat here that it's not so intimidating, or it doesn't look as hard here. So I multiply 2 times a plus 3 in parentheses, and that's going to equal 7 times 4. Now this is just a standard math problem. Right now you should know that you can distribute the 2 into the parentheses here. So I know 2 times a is 2a, and I know 2 times 3 is 6. And then 7 times 4 becomes 28. And so this is just a standard algebra problem right now. My goal right now is to isolate the variable, and to do that I'm going to subtract 6 from both sides. And I now have a 2a equals 28 minus 6 is 22, so 2a equals 22. And then the last step generally on proportions is dividing, and so we know a is now going to be 11. And if you want to double check to see this is correct, you can always plug that number that you have for the variable into the equation, and this a is now going to be an 11. I just substituted. And so we would have 2 over 7 equals 4 over 11 plus 3 is 14. If I cross multiply these, you're going to see that 2 times 14 is 28, 7 times 4 is 28, and since these equations balance out, you know that 11 has to be the right answer here, because when I plug 11 into the equation here, or the proportion, and cross multiply, they both sides equal each other. And so that's the easy way to double check if you've done the problem correctly or not. I'm going to jump into another problem right now. I'll do it in green, I guess. Again, I have another example here where I have more than just a variable, so I'm going to put parentheses around it, cross multiply here, and then 3 times 6. And so again, we're going to distribute the 4 into the parentheses here. This is where my students often mess up. They will remember to do the 4 times y, but they would forget to do the 4 times the negative 1. And then from here on out, they mess up. So make sure you distribute the number into both into whatever's in the parentheses here. In this case, it's 4 times y, and 4 times a negative 1 is a negative 4. And then 3 times 6 is 18. So right now, 4y minus 4 equals 18. Again, isolate the variable by canceling out anything next to it. So I have a 4y equals 18 over 4. Happens to be 22. That's just coincidence that both these problems equal 22 at some point. When we divide at the end, though, you see that y is equal to 5.5. Again, if you want to double check to see if this is correct, plug that 5.5 in for the y, and when you cross multiply, they should balance out and equal each other. They do in this case. I'm just not going to do it because otherwise this video would become super duper long. Jumping on to a different kind of problems here. Oh my goodness gracious. What am I doing here? We have 2 variables now. Whereas in the last problem we had only 1 variable. Now we happen to have 2 variables. Again, treat this lone variable like you normally would, but we need to put parentheses around this variable with a +1 right next to it. So n plus 1 in parentheses. We're going to solve this problem just like we did in the last slide. So 7 times n plus 1 equals a 9 times n. You always want to write things down the way you're normally used to seeing them. I'm not going to put the 7 afterwards and have an n plus 1 times 7, because you don't see that normally on math problems. But you are used to seeing the 7 in front of the parentheses here. And then I'm going to have a 9 times n here just because that's what you're used to seeing. When I distribute, the 7 times n is 7n. 7 times 1 is a +7, and that equals 9n. Now my goal is to get the variable on one side. So you always want to get the variable, let's say x on one side, number on the other, or you can switch it around whenever you're solving for variables. And so I have a 7 in here, I have a 9 in here. You always want to subtract the smaller number with the variable from the bigger one. I'm not going to go over why, but you do. So in this case here, I'm taking away the smaller number with the variable from the bigger one. So I have 7 equals 9n minus 7n is 2n. Now when we divide at the very end here, you're going to see that n is equal to 7 over 2. Sorry, I'm squeezing that in. And so this is equal to, and I'll just add it down here, 7 over 2 becomes 3.5. And so depending on what your teacher wants, you might want the fraction, you might want the decimal. I generally go for the decimal here. Again, and you can always double check by plugging in 3.5 into where the n is, and when you cross multiply, they should balance out and equal each other. So anyways, let's do another problem here. Let me zoom back up to the top. Treat this one like we just did. Let's go with red now. This is an x, or 8 times x. And then I'm going to put parentheses around this guy here. So we now have a 5 times x plus 6. Well, 8 times x just becomes 8x. A 5 times x is 5x. A 5 times 6 is 30. Again, subtract the smaller variable from the bigger one. So I'm going to take the smaller variable away from the bigger one. And you're going to see here that 8x minus 5x is 3x. This cancels out, so 3x equals 30. And so when I divide by 3 here, you get x is 10. Again, you always want to double check. I'm not going to do it here. Plug in a 10 here, plug in a 10 here, cross multiply. If they equal each other, you know you did it right. But I'm not going to do it here again. Next set of problems here even get more complex. On the last slide, notice that the variables were above and below. And so it says variables above and below up here. On the next slide here, they are now side by side. So x is on the left side, x is on the right side, x is on the left side, x is on the right side. What do we need to do? We're just going to continue doing what we've been doing. We're going to put parentheses around the things that are more than just a variable here. So we have an 8 times x plus 5. That's going to equal a 4 times x plus 13. And then I'm going to make the 13 not a b. But anyways, you're going to distribute the number into the parentheses here. So that's 8x. 8 times 5 is 40. And then 4 times x is 4x. 4 times 13 is 52. And then we always subtract the smaller variable from the bigger variable. So we get 4x plus 40 equals 52. Since you brought the variable to the left, I'm going to bring this number 40 to the right. So you always lead with the variable, and then the number always goes the opposite direction here. So I'm going to now subtract 40 from both sides. Again, you want to have a number on one side, a variable on the other, and I'm getting closer to that point right now. So 4x equals 52 minus 40 is 12, and then divide by 4, and we have x equals 3. So on this problem here, x is 3. Again, you can plug in this 3 up into this x and up into this x, cross multiply, and double check yourself. Always double check yourself if you have time. If you don't have time, solve the problems and then go back and I guess double check. Last one here. Again, parentheses around what's not just a number. And when I cross multiply here, 2 times 5x plus 4 equals 8 times 3x minus 6. So let's do this here. 2 times 5, x is 10x. 2 times 4 is 8. 8 times 3x is 24x. And 8 times, this is a negative 6. Sorry, my handwriting's getting sloppy right now. Is a negative 48. And then, again, we're always going to take away the smaller number with a variable from the bigger one. And we now have just 8 by itself on the left. That equals 14x minus 48. Since I brought the variable this way, I need to bring this number, negative 48, to the other way by canceling it out. And you get 8 plus 48 is 56. That equals 14x. We're always going to divide at the end here. And I get 4 equals x. Again, always double check by plugging it back in. The idea here is make sure that you put parentheses around both of these, and when you cross multiply, it just becomes a standard math problem. It's a complex one, but hopefully this video will help you understand it. One more thing, are you always going to get whole numbers here for answers? No. You're probably going to get decimals more often than you're going to get whole numbers. I designed these problems to be whole numbers just to make the math a little bit easier, but this could have easily been a 3.5 or a 4.7 if these numbers up here were a little bit different. Again, I just did this to simplify the problems. Hopefully this helps you understand how to solve more complex proportion problems, and I hope you have a super duper great day.